All right, so now we're moving on. We've gotten through the terms. We're moving on to logic and structure. And I think this will be the second video. I think we'll only need this second video this week. Hopefully. It's got 15 more minutes. I think I can get through the content. So when we talk about logic and structure, this is a couple of things. What does the code look like when you write it? What are the things that you need in order to make the code work, to make it successful? And one of the first things we talk about is keywords. So keywords are things that every computer, every language, right? Every programming language has keywords. Some have more than others. Some are limited, but all of them have keywords. And this is just a list of what all the keywords are. And all of these mean something very specific to the Python interpreter. Using these keywords gives it the opportunity to interpret and figure out what it is that it needs to send down to the computer so that it can process what you want it to do. You can write your own keywords, right? But these are the ones that are default in Python. There's packages that you can download that have other ones, but these are kind of the basic ones. And we're not going to go through all of these and talk about them through the class, but we'll end up using probably a lot of them, just because part of programming is using the language. So we'll be using this language. Now, instructions, when we talk about instructions in Python, these are statements that you write that perform a specific action. So we've already looked at some of these, but the idea of like x equals 5, that's an instruction. It's assigning the value of 5 to x. Now you can also do mathematic equations, right, where x plus 3 is equal to y. This is something that it's not algebra, right? So sometimes people look at this and they think it's algebra, like, oh, we're solving for x. But you're not solving for x, right? Because you already know that x is 5. This is just creating a variable that allows you to be flexible as you're going through the code, so that whatever x is will equal in and equal y. So when you do the math on the right side, you're not doing algebra. It's just arithmetic, right? You can treat it as if you know all the numbers, because most of the time you do know what the number is. Certainly the program knows what the number is, because remember, the program always reads from the top to the bottom. So if it gets to y equals x and it doesn't have a value for x, it's going to spit out an error. If it runs, then it knew what x was. And in this case, x is 5. 5 plus 3, we know, would be 8. So y equals 8. When it prints, it's going to print out print out 8 to the console. But this is considered a function call. So these are three types of instructions that you have. You have an assignment, which assigns a value to a variable. You have arithmetic, which does some calculation and still stores that in a variable. Arithmetic doesn't always have to store in a variable, but in this case it does. And then you have a function where you have, in this case, it's a function that just writes something out to the console. But every function does something different. And the nature of a function is that it has the function name, and then it has an open parentheses, and it has some parameter inside, and then a closed parentheses. In this case, the parameter is y, which we've already established is 8. So when it prints, it's going to spit 8 out onto your screen. So then we talk about indentation. Now, indentation is really unique to Python. Most programming languages use braces to determine when a function starts or when a function ends. But Python uses just this indentation, this spacing, tabs, at the beginning of a line. And that defines the structure of the code blocks. We call it the scope here. I usually refer to it as a block. So most languages use braces, but Python does not. And if you're familiar with another language, this is going to be something that's a challenge to you. Because in C++, the structure of it doesn't matter as long as you have the brackets or the braces in the right place. Python, the structure has to be exact or you're going to get an error. It's not going to run. So normally you could write it something like this, and this has no indentation. Name equals Sam, if name equals Sam, print hello Sam, else print hello dude, print how are you. This is all the correct stuff, but it's not in the right format, so Python will not be able to process it correctly. When we talk about indentation, we mean this space. We call it white space or a tab space before a line of code starts. When we say if name equals Sam, this colon here designates that we're writing an if statement, that there's some evaluation that has to happen in order to go to the next line. Once the evaluation happens, then everything inside this code block is going to run. So in this case, the only thing in the block is print hello Sam. But you could have any number of lines in there. You could have print hello Sam, print how are you, print my name. You could have lines and lines of output here. But as long as it was all tabbed over, it would be considered underneath this if statement, or inside, a block inside the if statement. You'll notice that the else statement here does not have a tab because it's on the same order as the if statement. So in the event that this if statement is not true, so let's say your name is Adam instead of Sam, right? So if you change this to be name equals Adam, then if name Sam, this code block would never happen. In the event that that code block doesn't happen, you're going to jump down to this else statement. And there's another code block here, which is exactly what's going to happen in the event that your name is not Sam. And similarly, this could have any number of lines associated with it. But in this instance, it's running this if statement, and then at the very end, it's printing how are you, regardless of what your name is. So because this is the same indentation as the else and the if, this is going to run regardless of what happens in the if statement or the else statement. The only things that matter from this if statement are the things inside of this block. And same thing with the else statement, but if it doesn't have a block, if there's no indentation, then it runs in the same line with everything else. There's a couple of ways to do it differently, but as a generic idea, Python uses this indentation to determine whether it's a block, whether it's part of a loop or a function. The blocks, the spacing is what matters. There's no braces for the most part. So then you can get to comments, and comments in Python are usually designated by a hashtag, a pound sign. Anything that the pound comes after the pound sign on that line is not going to affect the way the code runs. So when your interpreter runs, it ignores everything that's a comment. The comment is only for the humans, right? The comment might tell you what something does, but the interpreter, the compiler, they don't need that comment. They just ignore it and go on with their life. But generally, a comment is written either after something's written in the code, in this case x equals 5, after you assign the value of 5 to x, it just gives you an inline comment that explains what happened there. But you can put the pound sign at the very beginning of the line, and then the entire line is a comment. And usually that means you're explaining something down under it, generally. But if you put a comment, an inline comment, it explains just what happened on that specific line, right? But a full block comment can explain everything under it. But again, a block or a comment is designated by the hashtag. All right, so we have a couple of things left. I said we were going to get through all of it in 15 minutes. We're 8 minutes in, 9 minutes in. So I'm going to try not to go too fast. We might have a third video. So literals are just notations for representing fixed values directly in the code. So in this case, x equals 5. 5 is a literal number. This is a number that you have typed in exactly what it is. X is actually a variable. Right? Now, the value of 5 is assigned to x, but the number 5 itself, when you write it, is a literal value. So, generally a literal is something that you actually punch in, saying this is the value I want to work with. So there's numeral literals. So there's integers. Right? Now, an integer can be a decimal, it can be binary, it can be, this is called octal, or hexadecimal. Some of you are probably familiar with those terms, maybe from microprocessors. But any of these are considered an integer because it's a whole number. It's just a number that you can work with. Now, floating point literals are anything with this says a fractional component, but really anything with a decimal is a floating point literal. You can also have complex literals, but I don't really use those very often. But it just means that you're using real numbers and imaginary numbers. So this would be, this is just a function, right? Once you know J, then you know what it is. But this is a formula that you're writing. It's considered a complex literal. Some other literals that you can get to those were just the integers, right? These are just numbers for the most part. Others, you can also have strings, and a string is basically anything that is text. So hello world, Python is fun. This is all text. You can either, in Python specifically, you can use a single quote or you can use a double quote. If you zoom into here, you can see that this is a double quote and this is a single. The main difference here is sometimes when you're writing out a string, you want to use an apostrophe to designate like possession or some other grammar concept in English when you're printing something out. If you use the single quotes, then that apostrophe is going to read as one of your single quotes. If you use the double quotes, then you can put apostrophes inside of your string. I prefer to use the double quotes all the time. It's just a good habit to be in so that I never run into that problem. In the event that you have a string that is very, very long, you can use a triple quote, and that will allow your string to go across multiple lines. There's other ways to work around that, but the triple quote is probably the easiest one. Now the Boolean, this is a literal. The Boolean can be true or false. Those are the only two things it can be. So when you define it, you can type true, you can type false. Now you can also use 0 and 1, 0 being false and 1 being true. In a lot of cases you can do that because it's reading it as a 0 and 1. But true and false are going to be easier. There's also a none literal. You can set it equal to none. That means there's no value associated with it. And then you can use these literals in expressions. 10 plus 20, those are both literals, but they're assigned to a variable value. You can do the same thing with a string. You can add two strings together, and it will concatenate them. All concatenate means is adding strings. We'll talk in another video about just math in your programming language, adding strings and adding floats and integers. It's all a little bit different, but it's general concepts. Now you can also use a literal to define a Boolean. So in this case, is 5 greater than 3? Yes, that means this is true. If you had written 5 less than 3, this would return false. And those would be your literal statements, is true and false. So the thing we want to talk about, and we only have a minute and a half left, so I'm probably going to just stop and put this into its own video. We're going to talk about variables and what the variables mean. It won't be a long video, but I just don't have enough time left in this one to discuss it. So we'll start the next video with variables, and then we'll